Audio Jungle. Audio Jungle.
Question is, consider a two-dimensional, okay, consider two-dimensional potential flow. Potential flow. I told you potential means what? Steady, incompressible and aerodynamic. Okay, this was the GATE 2022 problems, right? GATE 2022 problems. Okay. If the over a cylinder, see the question, over a cylinder, we had seen cylinder case, we had seen one is NRC, non-rotating cylinder, and another was rotating cylinder, circular cylinder case. Okay, so both we had seen. If the free stream speed is given u infinity, maximum speed on the cylinder surface, we had calculated maximum speed on the cylinder surface. So actually the speed on the cylinder surface, we had seen two types of speed we had seen. What was that? It was, say, it was radial velocity, and another was, tell me, what was the another velocity? Say, it was tangential velocity, right? I had taught you cylinder two different cases, non-rotating and rotating cylinder case, but here it is not mentioned it is rotating or non-rotating. So we can generalize this. We can take anyone. Okay. So generally, if it is rotating cylinder, then they will mention. If they have not mentioned, it means it is a non-rotating cylinder. Generally, okay. So you know, for the speed, because they are asking what is the speed on the cylinder surface. So for speed on the cylinder surface, separately we had calculated radial velocity and tangential velocity. Anyone can tell me what was the radial velocity? What was the radial velocity I had derived? Anyone? Yeah, anyone please tell me what was the radial velocity? Last class I had derived. I mean last in the sense when I was teaching you that kinematics part for the rotating and non-rotating cylinder, then I had derived that formula. Anybody can tell that formula if you remember. If you remember, you please tell me what was the formula, radial velocity and tangential velocity. Both we had seen that value. Yeah, anyone? Ankush, Ayush, Madhuri, Ankita, Gayatri, anyone please tell that formula? Yeah, any one of you. Say, so the radial velocity was, it was nothing but,
Sir,
say yes please, u infinity,
yes, sir.
because yeah, u infinity, which is nothing but free stream velocity, because they have said free stream velocity is nothing but u infinity. So u infinity, first u infinity cos 1 minus capital R square by small r square. This was the radial velocity. Okay, and what was the tangential velocity? Anybody?
But small.
U infinity sine theta 1
Yes, sir.
plus,
Minus
no no,
1 plus, sir.
yes, this was the tangential velocity. Okay, if you see the problem, in the problem what they have asked, they have asked on the surface of cylinder. So on the surface of cylinder, on the surface, what is the radial distance on the surface of cylinder? Small r will be, say, capital R, right? That time what will be the radial velocity? Check. You keep small r is equal to capital R, then bracket value will be 0, so radial velocity becomes 0. What is the tangential velocity? See, it's nothing but small r and capital R both are same, then it is cancelled and 1 plus 1 will get 2, so it's nothing but minus 2 unit. So basically on the surface of cylinder, on the surface of cylinder, the final velocity, resultant velocity, or you can say resultant velocity, better you say. Resultant means only one velocity, that I will write only v. So v is nothing but we have only v theta because vr is 0. R is nothing but radial velocity. Okay? This should be if you are writing small r better, huh? Because v capital R means it's almost resultant velocity, but no issue because radial velocity becomes 0. So resultant velocity is nothing but now v theta only. So ultimately, if you think about the velocity part, so what velocity you got here? See, you got the velocity which is nothing but minus 2u infinity sine theta. This is the value you got, right? Minus 2u infinity sine theta. Now coming to the value of the maximum velocity, because here clearly they have mentioned maximum speed. The maximum speed means what should be the value of sine theta for maximize this velocity? When you will get this v max? So if v becomes v max, then this sine theta should be max. Sine theta value should be max, which is nothing but 1. So what will be the maximum velocity? It is nothing but 2 infinity. This plus minus, don't bother about it because here you have to see uh, because minus sign you are getting, that is correct one, no doubt about it, but here they are interested in magnitude only. Okay, so until unless they have not given a negative sign, then you will take the positive value because they are interested in magnitudes. If you keep magnitude because they are asking the speed, maximum speed only, so magnitude will be what? 2u infinity. This is your answer. So yes, Ankush, I think you had told this value directly, right? You had told this value directly here. Huh? Ankush, you have told, I think, right? This value.
Yes, sir.
This. Yes. So for your exam also, this is not required. See the radial velocity. Don't write each and everything because already it is discussed in class only. I had told you that on the surface of cylinder only tangential velocity will be there, and that already I had proved. And I told this is important for GATE exam also. And see this question directly they had asked. So once you are writing examination, then don't write each and everything. You should know what is the velocity. It is 2u sine theta. And if they are asking maximum velocity, so for maximum velocity on the surface of cylinder is nothing but v 2u infinity sine theta. But if it is maximum, then because u infinity is constant, it is not going to change. It is the free stream speed. So if you want to maximize this velocity, then sine theta value you should put maximum. And you know very well maximum value of sine theta is what? Only 1, which is nothing but sine 90, right? So and you know that range of the sine theta is minus 1 to 1. So for maximum value it is 1. Okay, I hope you understood that. And now coming to the next numerical, this one is clear. So option, which one is the correct answer? Option C is the correct answer. Okay, right. Now coming to the next question. This is again question asked in GATE 2021. And if you see this question, a free vertex filament oriented along z axis. Z axis means, see, this is what x axis, this is what x axis, this is what y axis. It is clearly mentioned y axis and x. So where is the z? Just perpendicular to the plane. Just perpendicular to the xy plane is nothing but z axis. Okay, so the free vertex is perpendicular to the plane xy, means it is perpendicular to the xy, that means in z direction. Okay, you can imagine that 3D. The strength k they have given, this is the strength of what? Vertex. The strength of vertex is nothing but 5 meters square per second. So every time notation they are changing. Sometimes it is gamma, sometimes k, sometimes omega. So don't bother about the notation. That notation they can take anything. So here they are taking k value. Okay, k is nothing but 5 meter square per second. Is placed at the origin as shown in figure. Where it is? See, this is the origin. Check the coordinate system they have given. This is 1 0 2 0 2 minus 2 0 minus 2 0 minus 1. All those things they have given. But here this is what? Origin. At the origin they have given, this is nothing but free vertex strength 5 meter square per second. Okay, the circulation around the closed loop. So they are asking a b c d e f a b c d e f and then again a. So it becomes a closed loop for this flow. Uh, so they are asking what is the circulation. The vertex strength k they have given 5 meter square per second. They are asking what is the circulation. for the closed circuit. So this is nothing but closed circuit. This is nothing but closed circuit. Okay. So for this closed circuit, so when I had explained the circulation, when I had explained the vertex also, that time I had told you, if the vertex strength, okay, the or strength of vertex is lying inside the closed circuit or lying inside the closed loop, then only you will able to find the circulation, because circulation is what calculated for the closed loop. That is one thing, but in that closed loop, that strength of vertex should lie. If it is not lying inside the closed circuit, if it is away, then you will not able to calculate circulation, and that circulation will be zero. It will be unaffected, right? It will be unaffected because your strength of vertex is what out of the closed circuit. So what will be the circulation here? Circulation is nothing but zero. So don't write zero, you have to keep zero value. That's all. What is your answer? Zero is your answer. Don't write zero, you have to put there. That's all. And the reason, in proper notes I had given in my previous lecture, if you go and check, so it was nicely explained. It is derived also why for closed circuit, if free vertex strength is lying outside the closed circuit, then y vertex will be zero for the closed circuit. That also I had proved. So you go and check. But here onward, I just want to give my statement. If strength of vertex lying outside the closed loop, then circulation for the closed loop or closed circuit will be zero. Okay, that you need to remember. Okay, because it's very clear why you are getting circulation, because of the vertex, right? And vertex is not lying inside the closed loop, then why you will get the circulation? You will not get, right? To get the circulation value, this free vertex should lie inside the closed loop, but it is not lying, it is outside the closed loop. So definitely circulation will be zero for the closed circuit here. All right, and it is already proved. You check your notes now. So the correct answer is zero here. Okay, I hope you understood this. Now the next question, again GATE 2021. Here they had asked, consider the velocity field. Okay, the field v vector is, oh, all right. You see this velocity vector, I have told you this is the velocity vector. Then for the x coordinate velocity component u, and y component velocity component j, how I should know this is, we have to take x and y component. How you should know? You see the velocity field, we have x y, we have x y, we do not have z. So now it is very clear. If you write z component also, so it should be 0k, because z component is not there. It means if you write the velocity for the complete x y z, so x y z, this will be the component x y z. Along z will have a w, along x we have u, along y we have v, but w we do not have, because if you see z axis is not there. It means the flow is what, only 2D flow. Okay, anyway, so now it's very clear, this value is u and this value is v. They are asking the field v vector is divergence free and curl free. What is the mean of it? Divergence free and curl free. Curl free and divergence free. Okay, we'll calculate curl and divergence. Very simple. So you have here, see the velocity component. What you have? U is nothing but 2x plus 3y. Check, 2x plus 3y. And what is the small v? See everybody, small v is nothing but 3x plus 2y. So what is the divergence? Divergence of v vector. Anyone please tell me what is the divergence of v vector? Yeah, divergence of v vector, if you know, already I have given a proper notes for the divergence and curl, do u by dou x plus dou v by dou y. That is the divergence of v vector. You need to calculate this value. Check what is dou u by dou x. If you calculate dou u by dou x is nothing but 2. What is the dou v by dou y? It is again 2. So you got 4. Okay. So here you basically divergence of v vector. Okay, if you see the divergence of v vector is nothing but 4, and this divergence of v vector is nothing but dou u by dou x plus dou v by dou y. So actually If you remember, divergence of v vector, basically you had calculated dou u by dou x plus dou u by dou y is equal to 0. If you remember, for the incompressible flow, I had shown you dou u by dou x plus dou u by dou y is equal to 0. That is the mean of divergence v vector. But here you are getting some value. What is that value? 4. It means divergence of v vector is what? Not 0. See, if divergence of v vector is not 0 because you are getting value, it means it is not divergence free. Check, it is not divergence free. One option, neither divergence nor curl. Neither. Okay, so two option you have, divergence free, not divergence free, uh, divergence free and curl free. Curl free. So divergence free. Two option you have, B and D. Again, you have to check for the curl also then, because not divergence we are getting here, because it will be a divergence. Divergence means is basically related to divergence of v vector. If it is 0, it means it is incompressible. So but it is not going to be a divergence v vector is equal to 0. So it means it is not a divergence free. It is not a divergence free. That's the mean of it. If that value becomes 0, then it will be divergence free. Then it will be divergence free. But if you see the divergence v vector value, divergence v vector you are getting not equal to 0. It means it is not divergence free. Simple, you just think about it. Divergence b vector is equal to 0 means it's a divergence free. What is the mean of divergence b vector is equal to 0? It means it's a divergence free. It's a divergence free. That's the mean of it. Means it is a incompressible. Means it is a incompressible. In terms of fluid flow, it's a incompressible. Means it's a incompressible flow. If it is 0, but if it is not 0, okay, then what is the mean of this? Technically, it means not divergence free. If it is not 0, it means not divergence free. Please just make a note properly. Not divergence free. Already I had taught you, once I had taught divergence, incompressible, rotational, there I had given the notes. So this is the not divergence free. Similarly, you have to find for the curl also, because both option they have given curl and divergence both. So you see the curl v vector, okay, curl v vector, right? So again you have to calculate curl v vector. So here only I am just going to calculate curl v vector. Curl v vector. What is the curl v vector? Any idea? Curl v vector is nothing but what? Verticity. If you remember, curl v vector was verticity. What was the formula? See, this is the xy plane. So what will be the verticity? Z. So tell me, what is the xi z here? What is the xi z? Say, it is nothing but dou x, dou y, dou v, dou u. Check, what is dou v by dou x? You have u is equal to 2x plus 3y. Here you have v is equal to 3x plus 2y. Now tell me, what is the dou v by dou x? What is dou v by dou x? This is the v only. What is dou v by dou x? It is 3. What is dou u by dou y? Say, what is dou u by dou y? It's again 3. So 3 minus 3, it becomes 0. If it is 0, it means xi z becomes 0. It means it's a curl free. Because verticity is nothing but curl v vector. So if curl v vector is what? 0, you are getting what? You are getting curl v vector, you are getting 0. It means if it is 0 now, it means it is curl free now. It means it is curl free. That's the statement. Okay, if does not equal to 0 means it is not curl free. Just like here, divergence v vector is 0, but if it is not 0, then it is not divergence free. So what is the correct answer? Not divergence free. Not divergence free. Both in B and D, both we have neither divergence but nor curl. So nor curl will be wrong because it's a curl free. So which one is correct answer? A. B, sorry, B is correct answer. I think this one is clear to all, right? So these all I have taught you well. The thing is, you need to revise your notes. Okay. Anyway, so B option is correct. Hope it is clear to everybody. Now moving ahead for the next problem. See, 8 2020. What is the problem here? Check all of you. The problem is the streamline of steady two-dimensional flow through the channel of height 0.2 meter. Channel of height 0.2 meter are plotted in figure where psi is the stream function in meter square per second. The volumetric flow rate per unit depth is. They are asking the volumetric flow rate per unit depth. Okay. The streamline of steady to the height in figure, right, per unit depth. Okay, no problem. So I have explained you that property of the streamline. See, these are the two different streamlines. See, these two different streamline we have, which is nothing but psi 1 and which is nothing but psi 2. Okay, I don't know how many of you remember. I had nicely explained this properly with the diagram. This, see, this is now proper channel between two streamline. We have a channel like this. Okay, and if you see the what is the flow in between these two is streamlines. So that already I had explained. It is nothing but, you can say, if psi 2 is greater than psi 1, if psi 2 is greater than psi 1, that can be any value. That's the reason we are writing a mod. So psi 2 minus psi 1 doesn't matter, or psi 1 minus psi 2. This was nicely derived in your class. It previous lecture, if you see, it was derived. So psi 2 minus psi 1, because you are writing mod, or psi 1 minus psi 2, is nothing but discharge per unit depth. This was derived in class only. Okay, what is the discharge? Discharge is nothing but, all of you know, volume flow. Say volume flow rate per unit depth. Okay, so this value they are asking. So what you have to do, simply you take the value of psi 1 minus psi 2, or psi 2 minus psi 1, just take the difference of it. That's all. See, any value you can take. Everywhere the value is what same. You can take difference between these two, or you can take difference between these two. Okay, it's your choice. You can see this value. You can check that difference. So what will be the value you will get? Basically, listen, basically, okay, if you see one thing they had asked clearly, the streamline of steady two-dimensional flow through a channel. Okay, in our case we had taken two different streamline, and we said this is now channel, like that. In our class we had seen like this. That is true also, no issue in that. But here in this case they have clearly made two different streamline, but they said channel is what here only. See, it is 0.2 meter apart. Now see, it is minus 0.10 and this is 0.10. So if you see the distance, this one is the 0 from the reference, this one is 0. So this is nothing but 0.10, and this one is nothing but 0.10. So they said the channel is nothing but this one. See, this is the channel. So in our, we have seen, see, like what we are learning, it is not necessarily the same line will be asked to you in examination. The small twist they have given here. What is the twist? Generally, we know that the is between two different streamline, whatever the flow is nothing but uh, uh, that flow is nothing but basically measured volume flow rate per unit depth. That is correct only, no problem. And this was the derivation I had given to you. But now they had said these two different streamline they are taking stream value. Stream value means one streamline that they are taking here, and another streamline they are taking here. How you would know why they are not taking this streamline? Because you have, this is one streamline, this is one streamline, this is another streamline, this is third, this is fourth, this is fifth. Total 5 streamline they have given. But why you are going to take this 1 and 2? Because in the problem directly they have mentioned the streamline of steady two-dimensional flow through a channel of height 0.2 meter. Means they are considering this streamline 1 and this is now 2, because they are considering the complete channel here. Hope everybody understood my point. Because if you take this streamline and this streamline difference, here also you will get the volume flow rate. There is no doubt you will get volume flow rate per unit depth, but that value will not be same what they are asking. They are asking two different streamline which are apart 0.2 meter, means they are asking, see this is the 0.2 meter, means one streamline should exist at this which is A and should exist at this is apart 0.2 meter. So you have to take these two different streamline. I hope this explanation is very clear to everybody. So now onward you will take one streamline here, another will be here. Now check what is the value. So psi1 minus psi2, what is that value? Check. It's nothing but 1.0 minus, check, minus again minus, so minus minus. Okay, otherwise I will write one more step if you are getting confused. So 1.0 minus again 1.0, because side 2 is down side, this one if you check it is minus 1.0. So if you check this value, so minus minus plus, which is nothing but 2.0 meter square per second. See the answer. Which one is correct answer? Check everybody. This is the answer one. All right. So I hope everybody understanding why you are not taking the subsequent streamline. Means you can say like, sir, you has told that two different streamline difference we have to take. That is okay. But that time you will get the volume flow rate per unit depth. That will be the value, but that will not be same what they are asking. They are asking basically the for the channel which is apart from 0.2 meter, means when you will get 0.2 meter apart, so that time you will take this one streamline here and another other streamline will be here, then only you will get the 0.2 meter uh, that both streamline will be apart from each other, it will be 0.2 meter. Okay, so then only it will make channel. So that's the reason you are taking this streamline and this streamline. I think this one is clear. Okay, now next question we have here, it's a gate 2019. See what the question they have given. Phi xy represents the velocity potential. Okay, when I had explained the velocity potential, that time I had told you the function, different function I had told. Okay, Laplace function and all. I don't know how many of you remembered, but if you see the previous notes, you will get. So velocity potential of two-dimensional flow with the velocity field. Velocity field is given u, okay, which is the function of xy, and v, which is the function of j, which is the function of x, y, j. Okay, where I and j are unit vectors along x and y axis. Correct. Respectively, which of the following is necessarily true? Which of the following is necessarily true? Okay, so all right, they have said necessarily true. So you know u is equal to dou phi by dou x and v is equal to dou phi by dou y, because you know the formula of the u and v. I told for the potential, because phi is the potential function, so for potential function in the same direction you have to differentiate, then you will get the velocity in the same direction. So u is dou phi by dou x and v is dou phi by dou y. This is the correct formula, but they have given this one, so this is wrong. Think directly, I can tell you what is the correct answer, but important also you should know why others are wrong. Okay, number one, this is gone. They have said necessarily true. So existing of the, if potential function is what existing only, then what is the meaning? Meaning is it's a irrotational flow. That already I have given in proper way in your class. I have explained this. When potential function is existing, it is already a irrotational flow. It is already a irrotational flow. That means it becomes curl v is equal to 0. So this is not a necessarily true condition. Okay, this is not a necessarily true condition, because it is already by default it is there. Okay, Divergence V vector generally define the incompressible flow. What it define? Incompressible flow. What it define? It's a irrotational flow. But what is this grad square phi? If anyone can remind the previous lecture, so grad square phi is nothing but, I had given it's nothing but dou square u by dou x square plus dou square v by dou y square is equal to 0. What is this? Tell me. Anyone? What is this value? If anybody can tell this. Grad square phi. So basically grad square phi is the Laplace equation. If I am correct, Laplace equation for the potential function. Check everybody. It's the Laplace equation for the potential function. If I am correct. Okay, so Laplace potential function for the potential function is existing. It means there is the possible flow. Huh? Because existing of potential function already told it is a rotational flow, but once the Laplace equation is what satisfied, then only it will be incompressible as well as it will be irrotational. So first of all, it should tell to you there is the possible case of the flow. So how you would know the flow is the possible? When Laplace equation is what satisfied. So once it is satisfied, it means there is the possible case of flow which is irrotational, already. So this is the one necessary condition, because you have to check first that flow is what possible or not. The flow is possible or not. If the flow is possible, then only you will check it is rotational or irrotational, it is compressible or incompressible. So how you would check for the potential function, how you would check it is possible case of flow? So for that I have explained you should satisfy the Laplace equation. So grad square phi is nothing but, grad square phi is equal to 0 is nothing but Laplace equation. Please remember this and don't worry, it is nicely given in your notes. I had taught you in previous lecture. You go and watch recorded lecture. So Laplace equation for potential function. So for potential function, okay, for potential function. Okay, so you need to remember that. I hope everybody understood my point. Yes or no? Yes, this was already explained in class. Yeah. Correct answer is option A. Okay, that is nothing but necessarily true. Here clearly they have mentioned necessarily true, and this is the multiple choice question, MCQ. If it is MSQ multiple select, then they will tell you, this is the multiple select. They will give the headline will be given to you. This is the multiple select. So one should be correct, because if phi is there, then curl be irrotational flow. That also correct. But what is the necessarily true condition? So necessarily true condition is you should satisfy uh, the possible case of the flow. So for that Laplace equation is given. You think if this Laplace equation is not given, then 100% option B will be correct without any doubt. 100% option B will be correct. But here, because Laplace equation is given, so you have to find A and B, both option will be there. You have to choose which one is the necessarily true. So that is A, because option A is the Laplace equation, and with the option A you will able to know that flow is possible, and once flow is possible, then it is clearly explained potential function is existing, it means it is a irrotational. So automatically B option is what considered under that only. I hope this one is very clear, right? Good. Now moving ahead, this is the another problem we have here. This is gate 2019. Okay, so see in this problem, generally we will derive that radial velocity and tangential velocity, right? Like just before one problem was there where we had written radial and tangential velocity. I think this one. See, this was we had derived, and we need to remember like that I'm saying. But see what they have given to you. Directly they have given the formula also. It is very rare, but here they have given the formula also. So nothing to worry. Your problem is 50% problem is sorted only. See the velocity, radial velocity they have given, and tangential velocity they have given. Okay. Okay. Now see, this cylinder is the rotating or non-rotating case. In viscid incompressible flow field resulting from uniform flow past a circular cylinder of radius r. Okay, centered at the origin. Okay, right. But where u r and u theta are radial and azimuthal. Azimuthal means tangential. So don't get confused. Okay, tangential. Component in polar coordinate. Obviously, u r and u theta are polar coordinate, radial and tangential. U is the free stream speed. Ignore the effect of gravity, right? The azimuthal location on the cylinder at which pressure coefficient is 0. And see, it's very easy only. Okay, its pressure coefficient they said is 0. We need to calculate the value of azimuthal location. I told you azimuthal means tangential, like azimuthal velocity means tangential velocity. So azimuthal location means, what is the azimuthal location? We have basically in polar coordinate we have r and theta location wise, but clearly they have said azimuthal location means they are asking the theta, and they are asking the theta in the first coordinate only. I have told you, I had shown the pressure distribution also on the cylinder, and it is very clear this is the non-rotating cylinder, because here in the complete problem if you read, then you will see they have uh, not mentioned about the circulation or vertex on the cylinder. So it means it is a non-rotating cylinder. So this should be very clear. Okay, nrc, it is a non-rotating cylinder, right? For the non-rotating cylinder, if you check TP formula I had given to you, and it is well known, well defined. See, if you remember the basically uh, pressure distribution on the circular cylinder, which I was explained there. If you remember that, then directly you can answer. But if you don't remember, then CP1 minus 4 is sine square theta. This formula you should remember at least. Now they are saying, simply they are saying, what they are saying, the pressure coefficient is 0. If you keep pressure coefficient as per the problem, I am showing, as per problem only, as per problem, they said Cp is what, 0. Then what is the 1 minus 4 sine square theta? What will be the sine square theta then? Check, it is nothing but 1 by 4. What is the sine theta? Check, it's nothing but, sine theta is nothing but plus minus 1 by 2. Agree with me? Then what will be the theta? Tell me what will be the theta, because we have plus 1 by 2 as well as we have minus 1 by 2 also. Now calculate the value of theta. What is the value of theta if sine theta is 1 by 2 and minus 1 by 2? Yes, please do it fast. What is the value of theta? It is nothing but, say, one is the sine 30, one is sine 30 is 1 by 2, another you tell me what is the another value where you will get minus 1 by 2. Put in your calculator, you will get it. Yeah, you can put in calculator, you will get what is the value of minus 1 by 2 in sine. What will be the theta there? Anybody? What is the sine 330? Any one of you, what is the sine 330? Yeah, anyone? Or see, first you can calculate in your calculator what is the value of minus 1 by 2 in sine. Sine theta is equal to minus 1 by 2. Then what is the theta value? One thing you can do, but I will give the clue for you. Simply they are saying in first coordinate, check. Actually, I want to just show one thing, but you are not able to calculate theta. I am asking you if sine theta is minus 1 by 2. My question is what is the theta, but you are not able to tell. Not a single student are not able to tell, but anyway. In the first coordinate they are saying. So in first coordinate, see the 30-degree sine theta, sine 30 is 1 by 2. So if you check the sine theta, which is nothing but plus minus 1 by 2, so means theta is equal to, you will take 30-degree and see this 30-degree in first coordinate only. So what is your answer? What is your answer? Tell me. Your answer is nothing but theta, 30-degree. Simple. If you are able to tell, if you are able to tell value of uh, that theta
Yes,
value,
sir.
you are,
30 होगा sir.
no, that is true. I'm asking, if sine theta is minus 1 by 2, then what will be the theta? Anybody can tell? Anyone? One student at least. If sine theta is 1 minus 1 by 2, then what will be the value of theta here? Anyone? Yeah?
330 डिग्री
330 डिग्री. वही तो बोल रहा हूँ 330 डिग्री, बट कोई बोल ही नहीं रहा है. ऐसा लग रहा है नो वन इज नॉट इंटरेस्टेड. So see, this 330 degree is in which coordinate? It is in fourth coordinate. You know very well that coordinate system, right? For the circular cylinder, if you see the coordinate, so 0 to 90 degree, 90 to 180 degree, 180 to 270, and then this is what? Basically 3, one complete circle, it becomes 360, right? So 330 you are getting here. But in the problem, clearly they have mentioned in first coordinate. What is the azimuthal location? Means theta value in first coordinate. So two value you are getting, one theta value you are getting 30, another value you are getting 330. So your 330 answer will not be acceptable. If they have given fourth coordinate, then your 330 will be acceptable, but in the problem they have mentioned in the first coordinate. So only 30 degree will be the correct answer, right? So your answer is nothing but 30 degrees. See, this is simple one. You just keep 30 because degree already it is written. See this problem. So many lines they have given, diagram they have given, formula, each and everything. But I would say it will not take time to solve this once you know the pressure distribution. I had shown you the pressure distribution for the complete circle. If you remember, this was the pressure distribution. See, something like this. This was the pressure distribution. Like that I had given, nicely I had given. You see the notes, check your notes. Okay, so what is the correct value? It's a 30 degree. Degree is given, so you just write only 30. That's all. Now coming to the another problem. See this problem, it is again GATE 2019. This is the problem. Once I had taught you the free vertex and forced vertex. The case of bucket I had taken, and I told that in full of uh, water you have filled in this bucket, and you just rotate, just insert your hand inside the fluid and just rotate your hand, so water will be rotating. Like that I had given example multiple times. So this is the only case. Now see, now read the question. A cylindrical container just like your bucket, radius of r 50 centimeter is filled, okay, with water up to height of h naught. See, till this water is filled. So earlier what was the case? Earlier the case was, it was like this. Just say this is the one container here we have. In this container water is what filled till this height. Till this height water is what filled. In this container water is what filled like this. But once you insert your hand, okay, and just start rotating it, then it is very I mean, without any expenditure you can go and do this experiment. So if container is there and water is what filled there, insert your hand and start rotating, so you will get this type of shape. This type of shape you will get. What type of shape? This type of, this shape is called paraboloid shape. What it is called? Paraboloid. It's a kind of parabolic shape, hence it is called paraboloid shape. Here it is written also. See, parabolic shape. Please remember this. Once you rotate, and once you are start rotating with the speed, if your rotational speed is what increasing, then this depth will be increasing like this. Then depth will be increasing like this. It will be increasing like this. It will be increasing. So if this container is what open, then fluid will go outside that time. Hmm. Because whatever the fall on the center, there will be rise on the edge. This is called edge. Think about it, because mass is what constant, amount of fluid is what constant. If there is no spilling out, means fluid is what not going. So once you start rotating, and if fast rotation will be there, then depth will be increasing in downward direction. So whatever the fall of water at the center will be the rise. This statement I need to write for this. So fall of water level at center is equal to rise of water level at the edge. एज मतलब वही किनारा, ठीक है. सी displaced upward h1 is 10. This h1 is 10. Earlier once there was not a rotation, then water was filled like this. Once you start rotating that fluid, maybe any rotor is there or anything, once you start rotating this, then the rise of water is given how much? Upward. Water is what displaced upward by h1 is equal to 10. See this height at r is equal to small r is equal to capital R. Small r is equal to capital R. See, so small r is equal to capital R means exactly at the edge, means at r distance. See, this is the r distance. This is the edge now. The magnitude of downward displaced h2 of the free surface at small r is equal to 0. What is the small r is equal to 0 means? It is exactly at this. The center of the paraboloid means exactly at the center. So what is the exactly at the center water? It is nothing but H2. So they are asking what is the fall. See, the downward displaced means fall. Downward displaced means there is the fall of water. Here we have a rise of water. So at the edge there will be a rise of water. Okay. At the edge there is the rise of water, but at the center there will be fall of water. It's a very bit with zero investment experiment we have. You can experiment after the class also, it is possible. No? If you rotate your hand inside the container, you take the bucket and fill the water and you start rotating. So you will see there will be rise of water near to the edge. This is nothing but edge. Okay, this is nothing but edge, and this is nothing but center. So at the center water will fall, but at the edge it will rise. But the question is what amount? So it should be constant only. The amount of the fluid is what? Constant. Once water is what not going outside the bucket, once the water is not spilling out the container, if water is what is still inside the container only, then whatever the rise at the edge, the same amount will fall only. Then only volume of the water will be constant. Because why it is happening? You can ask questions. See, it's very common and it's very special actually. And this was explained when I had taught the free and force vertex. So this concept I had given. So why this should be? Because that volume of water should be constant. Volume of water must be constant. I have to write must be constant. So when it will be constant? If somewhere there is the rise, then another place it should fall. Then only that volume must be constant, right? So what is your answer? Anybody can guess here? What is your answer now? Tell me. What will be the answer then? Anyone? Is centimeter. It is the fill in the blank. Anyone? See, this is the fill in the blank. Here we have to fill. What will be the answer then? Any idea? Amount of rise of water or water displaced in upward direction is 10 centimeter. Then what will be the fall at the free fall of H2 of free surface. Free surface means this surface. This is the free surface, right? So what is the fall? Fall is nothing but the same, because it is equal. Fall of water level at center is equal to rise of water level at the edge. So it is again 10 centimeter only. So what is the idea? The idea is very clear. Idea is very clear. H1 is equal to H2 always. But the condition is always when the water is what not spilling out. It is not, water is what not going outside. It depends on the rotation. If you are rotating uh, with very high speed, then water will go outside. But they have not mentioned anything water is going outside or not. If it is not mentioned, it means water is what not going outside. If water is not going outside, then always remember H1 is equal to H2. Means amount of water fall at the center is equal to amount of water level rise at the edge. That will be your answer. I think this one is clear now. This is 2019 question number 35. So remember, this is very easy problem, but technically it is very important. Okay, so you just now this is the again one more problem, 2020 2019 2 marks question. See what is the problem here. A two-dimensional incompressible fluid flow. Okay, a two-dimensional incompressible fluid flow is described by the stream function. Check psi is given to you. What is that? X y cube. All right, meter square per say second on the Cartesian xy plane. Very good. If the density and dynamic viscosity of fluid are 1 kg per meter cube, means they have given the density. What is the density they have given? It's a 1 kg per meter cube, and the viscosity of the fluid also. Viscosity means dynamic viscosity. It is given clearly. Dynamic viscosity means mu. What is that amount? 0.1 kg, okay, meter second. This is the unit of dynamic viscosity, mks unit. Mks unit respectively. Magnitude of pressure gradient in x direction at x is equal to 1 meter and y is equal to 1 meter, right? Momentum equation, I had given the Navier-Stokes equation when I had taught aerodynamics, and mass conservation when I had taught. After mass conservation, I had taught momentum conservation. In momentum conservation, I had taught momentum conservation along x, momentum conservation along y, momentum conservation equation along z. That I had taught, and also I had taught the final equation. This momentum equation along x, momentum equation along y, momentum equation along z is also called Navier-Stokes equation. And one master equation I had given for the Navier-Stokes equation. I don't know how many of you remember, but once I will write the formula, you will understand. And how you would know you are going to use Navier-Stokes equation? I will tell you one thing. See, very nicely they have given a dynamic viscosity, means it is a viscous flow. If the fluid is the viscous, two-dimensional incompressible fluid flow, if the fluid is the viscous fluid, it means here, because they are asking the pressure gradients, so pressure gradient, velocity component, you had seen pressure gradient, velocity component and dynamic viscosity you had seen in Navier-Stokes equation. So immediately that should come in your mind. And in fact density also you had seen in Navier-Stokes equation. All components were there. What was there? You had seen the velocity component was there, okay, dynamic viscosity component was there, right, density component was there, and pressure gradient was also there. dp by dx, dp by dy depends on x, y और z. इस पे निकालना है, उस पे डिपेंड करता है. So this pressure, this all complete package was there in Navier-Stokes equation, and this I had covered nicely. This Navier-Stokes equation is nothing but the momentum equation along x, momentum equation along y axis, momentum equation along z direction. Better you said z direction, x y z direction, right? That is nothing but Navier-Stokes equation. Now I am just going to write Navier-Stokes equation, and you try to connect that definitely you will understand. Okay, this equation already I have taught you in class. Check Navier-Stokes equation. Navier-Stokes equation. Okay, or also you can write the same momentum equation, momentum equation along one direction you have to take. So where they are asking, they have asked the pressure gradient along x direction, so better you write momentum equation along x direction. That's all, along x direction. Okay, now directly I am going to write the Navier-Stokes equation, because a derivation already I have done in my previous lecture. So what is the Navier-Stokes equation? It is nothing but rho, because think about it. Okay, they have clearly mentioned 2D. So and stream function they have given xy, and you know very well that also I have told you stream function is valid only for 2D flow. That also I have told you simultaneously. That also you need to remember. Hmm? So only 2D means xy plane will be there. There is no z component. There is no z component. Only xy, right? So for that reason, onward you have to write momentum equation along x axis, which is nothing but u dou u by dou x plus v dou u by dou y. Okay, this is the basically, if you remember, I had told you this was related to the basically acceleration part. If you see this u dou u by dou x, this is nothing but the convective acceleration. I had each and every term I had explained. Anyway, I'm not going into that deep detail because already I have taught you. Then right side it was minus dou p by dou x, okay, plus this is the frictional force or viscous force. It was nothing but dou square u by dou x square plus dou square u by dou y square. That problem is sorted here. Here only it is solved. Your problem is sorted now. See, the complete problem is what? You see the psi is equal to xy cube. Okay. What is the psi value? Psi is nothing but xy cube. What I want? I want dou u by dou x. I want dou u by dou y. So first of all, from the psi, I just want to calculate the velocity component. Okay. First of all, from the psi, I just want to calculate what is the velocity component u. Because everywhere it is given in terms of u, and v is also there. So we'll calculate both u and v. Now see what will be from the psi. You will calculate u. So how you will calculate? What is the formula of u, velocity component of u? So it is nothing but dou psi by dou y. What is the dou psi by dou y? It is nothing but, check, it's a 3xy square. What is the v then? V is nothing but minus dou psi by dou x. What is the value here? It is nothing but, it's a y cube, right? It's a y cube. Now this is the value here. What is the other? Once you got the u, then you calculate dou u by dou x also. Please calculate as much as possible. Time is also matter. So what is dou u by dou x? Dou u by dou x. See, dou u by dou x is nothing but 3y square. This is the value of u. So dou u by dou x. And what is the dou u by dou y? It's nothing but 6xy, right? Also you calculate, check everybody, check the value, which is nothing but dou square u by dou x square. So dou u by dou x already you have calculated. Calculate dou square u by dou x. So one more time you have to differentiate with respect to x. So no x function, so becomes 0. What is the dou square u by dou y square? Dou u by dou y is 6xy. So what is, one more time you have to differentiate, then you will get the, with respect to y you are differentiating, so you will get 6x. Now check, they have in the problem only they have given the x value 1 and y value 1 meter. All the value they have given x and y, which is given 1. You have to satisfied with the value. If you keep the value of x y here, so what you will get? 3. If you keep the value of y value, so you will get minus 1, because x and y is nothing but x is 1 and y is 1. It is given in the problem. If you see this value, what you will get? 3 only. What you will get here? It is 6 only. It is 0 and this is nothing but 6 only. You are satisfied with the x is equal to 1 and y is equal to 1. Now your problem is sorted here. See all the value. Rho you have, they have given. Mu they have given to you. All the value you have calculated. You just put in the in this formula and you will get your answer. Check. So I'm going to put here. See the rho value is nothing but how much it is given? 1 kg. Value also they have given simple one 1 kg. Check. U into dou u by dou x. So this is u and dou u by dou x is this. So it is 3 into 3. 3 into 3. Check. Then v into dou u by dou y. So this is v minus 1 and dou u by dou y is nothing but 6. So it's nothing but uh, plus minus 1 into 6. This is what? Check. This is the left side value. This is completed now. Is equal to, I am interested in dou p by dou x. This is the pressure gradient they are asking to you. Dou p by dou x. Okay. And mu value they have given to you. How much? 0.1. See, it is 0.1. Mu value is given. Now check what is the dou square u by dou x square. It is given 0 and this one is given 6. Keep inside. 0 plus 6. Now calculate minus dou p by dou x. How much you are getting? Check. It is nothing but 9, 6. It is 0.6. Sorry, this one is plus, right? 0.1 into 6. It is 0.6. All right. How much you are getting? 963 dou p by dou x plus 0.6. What is the dou p by dou x? Check. It is nothing but, what is the dou p by dou x you are getting here? Dou p by dou x, if you take this side, so it's 0.6 minus 3. How much it is? Minus of 2.4. So what is the dou p by dou x? It's the pressure gradient. 2.4. This is your answer. That's all. This is your answer. They are asking this value, right? Pressure gradient. So here you have to write minus of okay, minus. See, you have to check while you are putting the value. You have to check because they have said only magnitude. So magnitude means no need to put minus sign. That computer will not take that time. So magnitude. If you put minus sign, then it will be wrong. Computer will not. I mean, it will read minus 2.4. So it will not. You will get 0 marks. That's my point actually. So because they have said magnitude, so magnitude means this value. Dou p by dou x. So dou p by dou x magnitude you have to write 2.4. That's all. That's all. Simple only. Simple. This problem was very good actually. I like this problem because many times once I taught the Navier-Stokes equation, momentum equation, every year I am teaching to student, but I'm saying like, okay, question will be asked. So see, this problem was asked 2019 and it was very good problem actually. So only Navier-Stokes equation you have to use. That's all. So 2.4 will be your answer, right? What is the range of this? What is the range of this value? What is the range they have given in key? Tell me.
Sir, 2.3 to 2.5, sir.
Then it is acceptable. See the very minute 0.2 difference they have given, and exactly because whatever value they have given, they are no much more fraction. So it seems very clear to till 2 digit it will be 2.4. So that's the reason the very less range they have given because this all the data they have given very accurately. So that's the reason it should be inside that. You are writing 2.2 wrong, 2.6 wrong, right? So 2.4, this is your correct answer.